Thank you for taking your seats. We just had lunch, so I know everybody now is full of energy to go through the final half day of this event. So it's about presenting two projects. So we will start with the ÉALÚ-AER demonstration by Mr. Javier Camacho, UTM UAS R&D Senior Project Engineer at Collins Aerospace, and Mr. Cahal Macrostel, Manager at AirNav Ireland. After this, time allowing, we will take questions, and if not, then we will have a demonstration from the BURDI project run by Mr. Simon Devolderé, UTM Manager, SkyES. Again, we put the QR code on the screen so you can feed your questions. So please join me in welcoming the representative of the ÉALÚ-AER project, Javier.
Hello, everyone. It's me again. Someone suggested I should do this as a business and present on behalf of others. I wanted to say I hope everyone enjoyed lunch, and thank you very much earlier for all the insightful conversations that I had with a lot of people during lunch. And I was just joking, Javier is here, actually, he's going to do it.
Thank you, Wasim, for the presentation. What means ÉALÚ-AER? No? A lot of people can not even pronounce the word. No? So ÉALÚ-AER means escape air. We are proposing here an interconnected system, no? That because we believe that we require the proper infrastructure to conduct safe BVLOS operations. So what you see here is a diagram that represents the architecture of the project and the different systems that we have deployed. As Wasim very well mentioned, we are just close to the Shannon Airport. As we have deployed an end-to-end model infrastructure to support and conduct safely BVLOS operation mainly amongst other use cases in the close vicinity of Shannon Airport. So the U-space architecture that we deploy here consists of several systems, starting from a 3D SESAR radar, which indeed the system is Skyler. So this is what I was discussing yesterday in the panel regarding the surveillance system. I will discuss more further about this. We have also a series of CMPC radios that are deployed along the flight corridor, and as well, this was integrated in the drone. We integrated it in MANA. We integrated it in another platform. And the idea is that we maintain a secure C2 link along of the corridor. So when the drone is flying along, we ensure the reliability of the C2 link. This, to follow the safe of aviation standard, we have integrated with the ARIN Global Network as a backhaul network to exchange all this data. And we also comes with ADSB data. And all of this was integrated in a drone suite or a U-space suite that we call Collins Aerospace Services, that basically is a U-space and common information service provider, so USSP and CSP. So this basically is Collins Aerospace Services, what you see in the screen. So it consists of, on the left side, you have the view of the HMI view of the USSP. That is what the operator is meant to see. And on the right side, because we are in close proximity to Shannon Airport, we require of a proper system or an HMI to be provided to the ATC, as well as the vertiport manager role. That is something that I will show later in the display. And we develop an HMI for the CISP. No? So the project has been followed a sequential approach in which we have started from the less complex operations, basically to validate the systems from the less complex architecture to the more complex architecture. So we have divided in 4 phases. In the first phase, we validated the U-space with a visual line of sight flight. In the phase 2, we incorporate the active electronic scan array radar, which is the so-called Skyler. In the phase 3, we introduced the HMI view for the ATCO and for the ATS, and as well we introduced the CMPC radio that I mentioned before that will provide that reliable C2 link. And in the phase 4, we moved to more complex BBLOS operations. We conducted BBLOS operation of around 20 kilometer routes, and in this case we deployed 3 different radios along the route. So within this framework, 4 types of integration were provided to integrate the different platforms, so the drone platforms with the U-space. So in this case, we have the LTE tracker. So we provided in this way telemetry towards LTE network. There were also some drones that have a fleet management system that was in the cloud. So we integrated directly that cloud with also the U-space. We did also direct integration through Matlink with the ground control station. And we also integrated that telemetry through the CMPC radio that we have. So regarding the ÉALÚ-AER U-space architecture, I try to describe here a snapshot of the different systems and the different actors that were involved in this operation. So we have, in addition to the feedback of the local authorities, of course, and our UAS and aviation experts such as Deep Blue and F-Train, we also provided the 4 mandatory services such as network remote ID, geo-awareness, US flight authorization, and also traffic information. And on top of that, we provided also the optional service of the conformance monitoring. You will see that I mentioned that we have also provided some U1, U2, and U3 3 services. This comes from the Chorus ConOps, in which we were inspired by that. And since we had the surveillance system, we wanted to provide a tactical conflict detection service to the drone operator to be aware of, to have that enhanced situational awareness that we believe is required to maintain the safety of the BBLOS operation. And we also provided a procedural and collaborative interface with ATC and Vertiport Manager that we will see a demonstration now in a video. And C2 health monitoring is basically a service that we developed for the CMPC radio system that was integrated with the drone. So the drone operator can see and have that awareness of what is the status of the radio link, because again, we found that critical for maintaining the safety of that BBLOS operation. We have also some technology data provider, and we have also developed a kind of dynamic RP configuration that we have put in the CISP, as well as the kind of a module that we implemented to have that HMI view for the ATCO and for the Vertiport Managers. So in terms of the physical distribution of the different roles and actors, so you will imagine, okay, how is the visualization of, or the distribution of the different roles that we saw or the stakeholders that we saw that participated in the different demonstrations. And you can see that the use operator serves of the GCS HMI, and as well of the user screen with the U-space to be provided this kind of services. And on the case of the ATC, that I want to highlight that in this case this ATC was not on duty, for the sake of the safety of the demonstration. this had also the visualization of the ATN as well as the HMI of the different traffic information. No? And the vertiport manager have also that different visualization. So in terms of as we are moving towards the TRL 8, we require, of course, to be compliant with the different regulation. No? So in this case, we work on obtaining the different frequency license. That was we proved that was critical to engage with the regulator as soon as possible, because this system deployed in close proximity to the airport, ensuring that those systems doesn't interfere the actual ATM operations was critical. So we engaged with Ernaf Island in this case to ensure that that was the case, that wasn't interfering, and we engaged also with CONREG, which is the national regulator for the different frequencies. In order to install the radar, I think that yesterday I saw a question in the Slido that was actually challenging how the surveillance system can ensure that is covering the area from the surface and from the very low level. No? So indeed, very good question, and we did an analysis, of course, before setting this radar, actually to do through several simulations with different size of intruders that were possibly be located in the area, and we prove that, of course, this is also for the particularities of the terrain and the location, that we can cover an area from the almost the surface to something like the 300 meters AGL. That basically covers our requirements for notifying the traffic. No? So, and we have conducted, in this case, also some tests to validate according to a standard, which is the RTCA DO381. Some validations together with the support of Ernaf Island, in which an aircraft fly different patterns. So you have the patterns in the bottom right of this image, and according to the test cars that the standard demands in this case. So, okay, you will say, okay, now what do you do with the surveillance system? No? So in this case, that feed and that tracks that comes from the surveillance system was ingested or integrated with in the USSP as well as the CISP. So these are images that represent that integration and how you can see the feedback. In the USSP platform and in the CSP platform, you have the possibility to apply filters, so you can actually see what different sources you are checking. And in the case of the CISP, that FIC was fused with other tracks, so we can have a single picture of the portrait of the airspace. And this basically is a video that shows during the demonstration was recorded a few aircrafts pass over the area of operation. So indeed, we track with the scaler. So you will see this is the coverage of the scaler of the radar is represented with this kind of cone in yellow in the screen, and you see that as far as the track disappears from the get out of the radar coverage, it disappears. No, in this case, no? So we validated this through the demonstration, and this is just an example of how would use the scalar radar during the demonstration. I think this is just some of the video that's basically giving instruction that there is a warning to the pilot. No? So the pilot can take a mitigation action in this case. No? So and now, what about the CMPC radio? No? How we integrated the CMPC radio with all the UTN and the U-space ecosystem? So what you have on the left is there are some tests that we did on the integration with MANA in Ireland. And what you can see in the bottom is a representation of the ground-based station radio. So there are radio inside the drone and also in the ground to get that signal back, and that was fed to the U-space to get that image. And on the right side, you have some examples of how actually this is represented within the U-space, and how also was integrated with the other drone or UAS that we have in the project, that was the ÉALÚ-AER platform. And well, before doing the setting let's say the different radios along the flight route, we did of course an analysis to ensure how many radios are required within an area. So this could be eventually modular and can escalate and cover different areas. And we validated through some kind of simulator, and this supported as well the obtention of the frequency license to ensure that indeed we did an analysis that weren't interfering with other ATN systems in the area. This image, so we built a C2 health monitoring service. I mentioned before, we believe this is critical for and can support eventually the SORA or some risk assessment on the application for the UAV's flights. And we did some representation with different colors in terms of how the status of that signal and that C2 link status. We have a video also that basically what you can see is how the different lines change color as the drone is moving, representing the status of the radio link is being updated. You can see the drone in green in the middle, and this was one of the demonstration of the open data that we did for ÉALÚ-AER. And of course, we are working towards the U-space designation. We didn't define yet officially, but we are working towards that, doing it in the project. And we divided, together with the support of ERNAF Island, we developed this sectorization of the airspace towards that we indeed is the area where we were taking the flight. This was actual Class C airspace, and eventually it will be designated or modified as a U-space airspace. And the idea is that with this sectorization, only one of the areas is, in the case that there is some manned traffic that needs to pass over the area, only one of the areas will be dynamically reconfigured in this case. So now I'm gonna go over a workflow of how is an operation from the start of the operation to the end. So you can have that visual of how actually is the workflow of the different services during a real operation. So I'm gonna play. So the drone operator basically creates the U-plan. Is according to the regulation, to the Annex 4 of the Regulation 664. And well, it basically creates some fields, the loss of C2 link. Then when the U-plan is created, the drone operator do the last checks prior to the operation, and they will receive that the authorization is pending. Why? Because we make it as purpose that if we are in CTR, the drone operation needs to go for approval by the ATC. So what you see now is the HMI of the ATC. So the ATC can see the operation, go to the details, and depending of the traffic, can approve or reject that. So this will be like what we call the procedural interface with ATC. So once it checks the details and check everything is good, is the pilot is ready for takeoff. So it will request the takeoff clearance. So we now need to do back the tactical now decision. So the pilot will request the takeoff clearance. And since we are in also taking off from a vertiport, we made in the workflow that the vertiport manager needs to approve first. So the vertiport manager now is approving. And now, once the vertiport manager approves the operation, it will go back to the ATC operator. The ATC operator can accept or reject it, approve the operation, and the US operator takeoffs and activate the operation in the UTN platform. Maybe I'm gonna remove the sound. Yeah, I will play it. Yep. Wait. Somewhere. Yeah. Okay, so the drone operator take off, activate the operation in UTN, and that area that you see in green is basically means the operation is activating now. So the drone can take off, no? So the vertiport manager will monitoring can monitor through the cameras, and then the operation starts. So basically we can see now that the drone is conformal, is within the volume, and the ATC operator, in this case, can also monitor the status of the operation and have that situational awareness of where is happening that operation. No? The team can monitor through the different locations and follow the flight, and as well the vertiport manager can also have that visual of where are is the operation being conducted. No? So what you see in blue is means the drone, and what you see in yellow or orange are the other traffic. And maybe yeah. And we see now we can follow the C-tooling status through the different CMPC ground radios. So the drone pilot is always informed of the status of that C-tooling, no? Which we consider critical. And basically, you can see how the volumes, the 40 volumes, are also getting updated. And that's conclude the operation. So now I'm gonna put a video that we performed in the open day. Hopefully we have sound. I don't know if we have sound. Let's see. Yes, we have sound.
What's ironic about anything that we do from an individual point of view in air traffic services particularly is that it moves very, very slowly. And the key to all of this project that we're involved in is a demonstration of digital skies.
The whole idea of this project started with a simple conversation with a couple of engineers saying, hey guys, what about deploying this? The SESAR joint undertaking instrument that helps us get the funding in place. So we knew that the project would get accepted even from that conversation.
As we see air mobility advance, we're going to need to have much more integration of smaller vehicles, more autonomous vehicles, and indeed, passenger vehicles and cargo into the airspace.
How do we bring them together? How we connect them? How the differentiated capabilities that they have together make something bigger?
We have the problem of the situational awareness, so being the drone far away from the side, so opposite to the manned aircraft, where there is actually the pilot on board of the aircraft. So we need to have kind of situational awareness to be able to maintain the safety of the operation.
We are deploying capabilities around communications, so the CMPC solution. We are deploying capability around observing small drone-type aircraft in the environment using a SCALAR system from Collins.
The SCALAR product is a radar, an X-band radar. It's a multi-mission radar. It can detect birds. It is an advanced weather radar. It's So it really does 3 or 4 different use cases in one panel. All the systems that we are deploying need to be correctly integrated with each other, such as scanner radar, the CNTC, adding global network to exchange all this in a data chain, and also the key element on this point, which is what is our special issues, that is able to support the online traffic management platform.
The path towards how we integrate the digital technology with our own digital technology that is quite a closed system, and point the path and direction for how that's going to become integrated with manned air traffic in the future, and then the now even as well.
The problem we're trying to solve here is the identification of drone activities in a controlled airspace, the likes of Shannon Airport.
It's giving us a platform that we can actually look at to see how it works, how it operates, how we can look at ways of integrating it.
The largest obstacle is to try and integrate 3 or 4 products, get regulatory approval for something that's completely new, and we're trying to prove to air traffic control and regulators in Dublin that what we're doing is safe and secure. I don't think there's many places in the world where you can find this kind of ecosystem, so it's been really, really helpful for us.
The project will accelerate the understanding and the implications, the business model and the viability of deploying such services in the country.
I see the future with a lot of drones operations flying in the sky, one doing medical delivery, another carrying passengers, another for the police, another for medical goods. Being able to put all these pieces together and this infrastructure together, which is scalable.
Once it's deployed here, it can be rolled out across the country and go beyond just the country, goes to Europe and maybe beyond as well.
It's bringing all these bright minds together, being able to do cool stuff and do it hands-on, show people what's possible through demonstration, and then turn that into the future products for Collins.
I see a really bright future for air traffic management, but I also believe that we need to be on board with everything that's happening so that we can better inform ourselves, and ultimately the best thing an ATCO or an air traffic controller wants to do is filter out as much of traffic that they don't need to know about, and this is a way to do it in a real world technological solution, and as a result provide a better service to all aviation stakeholders. Cool. Okay, turn me off. It's cool, isn't it? It really is cool. It's great. They did ask if I wanted an actor to play my part in the video, but Brad Pitt wasn't available, so I had to do it. What can you do? Okay, I have no slides, mainly because I didn't want Wasim coming in to try and steal my thunder. But equally, it gives me a chance to talk and tell you my story, or our story, because it's us. At the team I work with, the guys from Collins, FMCI, and everybody else from a regulatory point of view, our colleagues from the IAA, our regulator are here as well, and we're all part of that ecosystem in making things happen, making things work. I get to tell my story a little bit, as I say. So I'm 35 years working in air traffic management, started my career in 1990. I've been an operational ATCO, watch supervisor, instructor, operations manager for Cork and Shannon Tower business units, where I first became exposed to drone operations and drone activity generally. And since then, I've taken up my current role, which is manager for airspace and navigation within the ANSP, dealing directly with flight procedures at Dublin, Cork and Shannon, but equally U-space or drones have followed me from my time in Cork and in Shannon tower units, and I'm now based in Dublin. So 35 years in the job. As Jean-Pierre mentioned earlier on, that makes me a dinosaur working for a dinosaur, being that ANSPs are dinosaurs. And to that point, I do want to sort of go back to giving a little bit of credit, where I wouldn't have given credit before, I am giving credit now to the likes of EASA and our own regulatory colleagues within Ireland. In the development of the 664, or the EU Reg 664, pardon me, Article 5 was particularly contentious in regard to dinosaur ANSPs being kept outside the door of potentially doing CISP and USSP, or choosing to do one or the other. And now obviously that was amended slightly. But the thing that made me realise that we needed to think a little bit more open-mindedly. ATM as a standard is quite slow to change, is quite sort of monolithic, moves slowly, and doesn't like change. And ATCOs definitely don't like change, so what are you going to do with those guys? They just don't want to know. However, to try and demonstrate an element of evolution in my mindset, which takes a lot, like I am quite conservative or have been quite conservative through my training, through my experience, but it opened up my mind to think actually, as I think as Jean-Pierre said, the regulation forced ANSPs to think a bit more differently. Forced is a strong word, but it's a word that's relevant because you have to actually start thinking a little bit more broad-mindedly about what it is you want to do, where you fit in this ecosystem, or do you just ignore it and hope that it goes away? Because it ain't. So that, again, I do want to give credit from a regulatory point of view, and again, touching on something Jean-Pierre said earlier, as did others, the key to all this is early engagement with the regulatory people to bring them on the journey with you so that they can have the confidence and the evidence to be able to sign off on what needs to be done to make this all work. Second thing I want to do is just give a little bit of credit to the SJU. Again, being skeptical by nature and an ATCO by training, nothing to see here. What could they possibly bring to the table? Evolution for me, as well as for everybody else. So I did used to think that a lot of the SESAR joint undertaking projects and the SDM projects were solutions looking for a problem rather than solutions to problems. However, through the interaction, and I have to give huge credit to Genghis and his team, as well as particular mention to Olivia, who really put us through our paces as part of this project, because it is about innovation, it is about seeing the future, it is about making something work. So I do want to pay credit to the SDM and SJU in that regard, as bringing me on a journey personally, as well as bringing the ÉALÚ-AER team along with them too. So credit where credit is due. As I say, I get a chance to give you a little bit of my story, and I do want to sort of focus a little bit on history. So I wonder, does history ever teach us anything? Mostly globally, we're seeing exactly the same kind of things happening now that happened 100 years ago. So there's a good chance that history teaches us absolutely nothing. However, if you look at history in its purest sense around aviation, Ireland is an island on the edge of Europe. We have no choice but to fly if we want to get off the island. We interface with the ocean. We've had a huge amount of aviation history in our background, be it Charles Lindbergh setting up flying boat base in Foynes, or Wrongway Corrigan, who was apparently going west but ended up in Ireland, Alcock and Brown, all of that sort of goes up. So we had flying boats flying into Shannon, to Foynes, where Irish coffee was invented, by the way, going back to the 1930s. Shannon Airport then developed as a result of that. And what makes Shannon particularly unique in that you've got this mix of traffic, as has already been spoken about. You've got commercial traffic operating to the longest runway in Ireland. You've got general aviation traffic. You've got search and rescue traffic. You've got airline trainers regularly using it. When I started in the job, Concorde used to do training, used to do circuits in Shannon. Like that's the kind of history that's there. So it makes it the ideal place to bring all that history together in a future context with everything that goes with it. When I, again, started my career, and I do want to sort of look at separations, because this is supposed to be talking about how we bring from segregation to integration. And when I started my career, my first rating as an ATCO, and remember this now, this is 1990, so I know it's not that long ago, but it's last century, and it certainly felt last century. In 1990, the environment in the en route centre where I was training was a procedural environment with a radar backup. Radar was, something that was kind of there in the background. So procedural means that you had a row of strips, and you could have 20 or 30 strips. You had to mark them with a pen and ascertain the position of aircraft based on that annotation, what flight level, etc. So when you're doing your first rating, I want you to think about this. You've got two aircraft, you want to vertically separate them. You say to the first aircraft, descend flight level 210, report leaving flight level 220. Once the aircraft reported leaving 220, that level became clear for the next aircraft. It didn't matter if it was descending at a foot a minute, or 20 feet a minute, or 200 feet a minute. That separation standard existed, and it had a buffer within it. Move forward into the new world, or the now world. We have all this digital data. It's all a radar environment. It's all about digital data, safety nets, tools, assistances to ATCOs. So why don't we look at a separation standard now that reflects the amount of data that we get. If we were able to rely on something that you couldn't see 20, 30, 40 years ago and assure separation based on those criteria, why not use the data now to inform where we want the separations to go for the future for all aviation stakeholders? And to that end, bring the regulator on board, bring EASA on board. And then the next question is, do we actually really need U-space at all as a concept? I've an open mind about it. Yeah, I can see U-space as being a step towards where it needs to get to for integration. We have a well-worn phrase in the ATM world that best equipped equals best served. And the same should apply to drone operations. The better equipped the drone, the better the access they get to controlled airspace, and maybe call it Class C airspace or Class C Alpha airspace, where it is available for drones that have reached, or drone operators that have reached a particular technological capability and can assure separation. Since 2012, I've been engaging directly with drone operators, and this 2012 now I'm talking about, where it would take me 2 hours to write up a notice about a drone operation that was happening somewhere within the control zone in Cork or in Shannon. I can do it in seconds using the digital technology that Collins have developed through this project, and the team have sort of all fed into. Equally, in developing a system, what I really like about the regulation, it only requires the mandatory services for a USSP. That's the right way to go. The more engineering solutions you provide for particular operators, the more problems it generates. Ask the operator what they need in the now, deliver that, and then build on that. And that's key to me in everything we do. If an ATM system provider comes in and says, look at this, look at this, look at all these bells and whistles, isn't it great? The ATCO will look at it and say, don't need that, don't need that, don't want that, we'll never use that. And straight away, you shoot down the argument. Apply the same logic in a digital world to what we need to do for the future. So, I'm going to try and close it on that. I really do believe that we can move towards integration properly. What we did in this context was have a segregated block of airspace, and think about what you saw in the video. An active runway less than a kilometre away from where the drone was actually flying. But again, conceptually, think about it. The runway is on this side of the airspace. All of this airspace out here is free to be used by whomever wants to use it. All we need is data, and be able to share data from the drone, with the general aviation, with the search and rescue, with parachute, paragliders, whoever it may be. So we've heard of ADS-B, ADS-C, and ADS-L, wearable technology for the likes of paragliders. It all works, it all fits, and in my experience since 2012, I have never had a concern that there's an issue with drones. Yes, there are illegal operators, yes, there are non-cooperative operators. I've never seen an issue in that time, which is not far off 20 years now, of drone operations in busy CTRs, in Dublin particularly, in Cork and in Shannon, where an issue has arisen. So all we need to do is pull the data in, pull it together, and share the information and develop the separation that is needed to bring segregation to integration. So the main message I have really is, let's not forget our history, because it informs where we've been and what we need to do for the future, and embrace the new future ecosystem. Thanks a million.
Thank you very much. So we had the demonstration and the vision, and I'm sure this is triggering some thoughts. So please, it's a Friday afternoon. We'll try and make it more interactive, maybe, to end up the event. So if you have questions from the floor, turn on your mic and feel free to ask them. If nothing comes up right now, we can move to the next demonstration, which is the BURDI one. And then maybe we'll see if you get brave enough to push the button and ask your question. No? So let's go for the BURDI demonstration, please.
Good afternoon, everybody, again. BURDI demonstration is on the agenda. You might have witnessed that on the official agenda, Simon de Volder was announced as the lead. This is the beta version you're looking at. So happy to be Happy to be back. In the end, it's Friday afternoon. I have good news and I have bad news, and I'm not sure which is which. The bad news is weather hasn't permitted us to fly today. Yesterday was really bad. This morning was bad at 70 meters. This afternoon was more or less okay. Nobody predicted it. So there's no flights going on. News number one. Don't know if that's bad or good. News number two, we're not flying. Hence, this demonstration will be a little bit shorter. Hence, your weekend will be a little bit longer. I'm not sure whether that's good or bad news. Make your choice. So let's move on maybe, because rather than looking at some live flights, which would have been which would have been nice, I was meant to say. But in the end, I'm kind of thinking at the same time, we all know that drones can fly, do we? So having a show where we can see drones flying around is maybe not interesting. So as an alternative, I went for the boring stuff. And the boring stuff is explained to you more from a technical insight. But before going into the boring technical insight, so for those non-technical ones, after the introduction, feel free to have a nap. There is a video coming. Please come awake when the video starts. I'll remind you. This is the list of customers that were involved, USSP customers. Again, here, my speech or my part of this presentation is again representing the USSP in this equation from a Skydrone perspective. But this slot was all meant to be, and still is, meant to be filled by the operators, sharing their experience, showing their platform. So this hour and a half, which now will be shorter, was meant to be filled by all the drone operators that were participating. You see them listed there on the screen: SAPCA, Helicus, FlyingCam, Infrabel, Drone Matrix, and Skyports. We have 2 of those operators that were prepared to actually do flights this afternoon. In exchange, or rather, instead of being able to show those flights, people were working all through the night. So a big thanks to those people in the background, by the way, that rather than preparing the flights went into video mode. So plenty of the videos, well, most of the videos you'll see now were actually produced during nighttime. So thanks for that, for everybody that was participating in that one. Maybe a quick overview of those operators. You will, after me, get an even better version of me, and that's Michael Shamim. He will explain what Helicus is doing and showing the video that they made using their own platform, but also using the USSP platform. Right after that, so right after Helicus' speech from Michael, there will be Drone Matrix, so Frederik volunteered to also come and present rather a video than his live flight in the port of Antwerp. So those 2 gentlemen will come after me. I will mention the other ones. Infrabel, I don't know if Martin is still in the room. If he would have been yelling. Where is he? He's not yelling, so he's not in the room. Infrabel is the drone operator. Well, actually, Infrabel is the company that is in charge of all railway infrastructure in Belgium, and they have their own drone team with their own AI team after that. So they do quite a bit of BVLOS drone flights to inspect all the railway infrastructure in Belgium. So a pretty big and important operator. You'll also see FlyingCam. FlyingCam, unfortunately, in the meantime, has gone into Chapter 11. They have been known, or they were known to fly. A lot of the James Bond movies were actually fed by drone pictures taken by FlyingCam. Unfortunately, as I said, turned out to be not a profitable business after quite a long number of years. SAPCA is an aviation company that has a drone division that was more involved in governmental flights over the North Sea, for example. They are not here today, as far as I know. So this is kind of the set of the 6 drone operators that participated in the BURDI project. As I said, now starts the boring part, so feel free to have that little nap discreetly. This is an overview of, in the center you see the Skydrone platform. By the way, it's powered by Unifly. So Unifly is a software company that provides us the software solutions, the SaaS solution that we run as a platform, as a USSP. We combine it with some of our own, but I'll mention that later on. So it's powered by Unifly, and what I wanted to do is remind all of you, because later on in the movies you will see a quick overview on how those services are being used by the operators. But to remind you all and to give you some room to have that little nap, I want to go through those services and see from a technical point of view what that means. So service number one, on the left side you see our customers, so the drone operators. On the right side, our platform. Pretty straightforward. What is GeoZone information? So the geo-awareness service provides information in real time to the operators on where the geozones are. Where is that information coming from in the background? Well, on the right side of the slide you see it's coming from the CISP. Today we will not be showing the CISP platform. I could have been able to demonstrate that, but you should believe me, and believe me, it is a platform made available by Skies where we get that information from. It's one of the two elements that come from the CISP. That's pretty straightforward. Now let's then move on to the next service, which is the flight authorization service, and that's actually an exchange of flight plans and associated authorizations. You see plenty of that interface later on. What is being used there? Well, it's a deconfliction service that is based on the knowledge of the flight plans coming from other USSPs. Straightforward. Then the network identification service. I know that all of you will vividly remember that one slide that I presented yesterday on the 3 options for network identification service. I will not turn it into a quiz, but I could, but I won't. The first one is, remember, direct remote ID. So we have a number of direct remote ID receivers. It's not our preferred solution, by the way. We also have network remote ID. Remember, a network remote ID device on the drone that talks to our servers, but definitely for the sake of these demonstrations and the flights, our main network identification source is the telemetry coming from the drone operator. You'll see that later on, both from Drone Matrix and Helicus. We have a direct connection with the ground control system of both of the operators. So the actual live location of the drone is fed by the drone operator itself through a telemetry link into the GCS API that exists on our platform. What is done with that information, the network information? Well, to keep it short, I've mentioned on the right side the rest of the world. Remember in the presentation this morning, the network identification live data is exchanged with all USSPs through the inter-USSP platform. It's shared with even the general public, and it's being shared then with the authorities through the CISP. Traffic information. Remember what was that? It's providing the network operator with a full air picture. So both crewed and uncrewed traffic is presented to the drone operator. What are the sources there? Well, on the right you see our own infrastructure, including, by the way, the information that comes in from other operators through the telemetry. So it's information being provided either by the other operators or through our own infrastructure, and that's definitely the case for crewed aviation. Remember what I mentioned yesterday, we have a number of ADS-B receivers, we have a feed with Skies for radar data, and we have a feed coming in from Safe Skies. So in controlled airspace we get the information from the CISP. Remember what I just said, geo information is coming from the CISP. Live data on crewed traffic in controlled airspace is fed by the CIS. So there's 2 APIs available on the single CISP platform. We're using one of them. Well, we're using actually both of them. That's about it. What I now wanted to do is maybe give a little bit more insight in the actual technical platform. So for the non-technical ones, bear with me for a minute or two. I'll start with the geo-awareness service, or let's move on rather. Well, something is, okay, let me go back. So what I've mentioned in the beginning is the one by one now, the geo-awareness service. Look at the architecture at the bottom. What you find at the bottom is what Skies is providing. So Skies, as has been mentioned many times, has been designated and certified as single CISP in Belgium. What do? Well, they use their own data for dynamic airspace reconfiguration. So the DAR data coming in is also being fed on the CISP platform. By the way, as Simon mentioned this morning, DAR is actually not implemented in BURDI yet. We're limited. We have to, due to timing constraints, limit ourselves to the port of Antwerp, but once dynamic airspace configuration becomes active in controlled airspace, that's a feed that will also be provided through the geo-awareness service. So it's actually the limitations of the DAR are fed into the geo-awareness service. Where are those data coming from? Well, the single CISP gets those data from the Belgian Civil Aviation Authority. That's for the geo-awareness. If we now look at traffic information, as I mentioned, crude traffic for controlled airspace is also fed through the single CISP platform. And then there is the famous, what has been mentioned earlier, inter-USSP platform. So it's not part of the CISP infrastructure. You can consider SKYS there as a third party. And what does the inter-USSP platform do? Well, first of all, it arranges for the exchange of network identification service. Remember, live location data of the drone. It also accommodates for the exchange of the flight authorizations. Remember, the flight authorization does deconfliction of flight plans among the USSPs. So that's what the inter-USSP platform helps to do too. Why am I saying that? Well, this is the more complicated version of what I tried to simplify on the previous slide. I'm not going through that one by one. What I want to do is nevertheless zoom in on what you see in the center. So what we now have is a zoom in on the full architecture of our USSP platform. What you see on the right is the UAS operator. What I want to do is basically run through that because it corresponds to the movies that you will see later on. And let's have first at a look at where the APIs are being provided. Well, the API has different purposes. There's two of them. There is a network identification API, the one you see at the bottom. So the live UAA position comes from the operator and is fed through a telemetry link in our network identification service. That's API number one. API number two is that the traffic information that you see on top, the yellow line above the UAA position data, is the full air picture. So the traffic information is also fed as an API to the operators. I'm going back to the brilliant presentation that was given just before me. The whole idea that we have as a USSP is to make life easy for the operators. If we offer them something that they don't want, we better not do it. What does an operator want? It doesn't want it does not want a second screen. So that's why we provide the traffic information service, for example, through an API so that they can integrate it on their own software. You will see that in both cases later on. So rather than having a separate HMI, believe me, a drone operator doesn't want to have more than one screen in front of his eyes. So having it maybe nice stuff on a mobile phone that flashes and does all sorts of nice stuff, it might sound sexy and look sexy to all of us. It's irrelevant to a drone operator. So that's why we offer it through an API. If we then look at the HMIs that we currently have, and again, the platform together with Unifly is under full development, or rather, I would say by Unifly is under full development based on some of the experiences and the learnings that we got from the BURDI project. It's actually feeding, as we speak, the roadmap of Unifly. What are the HMIs that are available on the platform? The common conformance monitoring service is the one at the bottom. That's providing alerts to the operators. Another one is the flight authorization service. You'll see that later on. It's still in further development. So although the flight plan can be fed through the API, some of the interventions still require manual, or some of the elements require, still today at least, manual intervention. Again, some of those issues are roadmap issues that will be solved before we get operational. The traffic information, so the full air picture, is also available over HMI. So if you're not using the API, you can still, for the non-technical people, the API is basically a link between two computers, and HMI is a human-machine interface. So it's something you can look at. A browser, for example, is an HMI. So that full air picture traffic information is provided both on API and on HMI. And of course, also the geo-awareness services is provided over the HMI. This is a screenshot. You will have far more information through the videos that are coming up, but just a rough example of the geo-awareness service where you see the geozones. The strategic flight planning and authorization is something that will be looked upon in more detail in the video. that's an example of a tactical flight activation, but rather than launching that video, I just wanted to maybe start with another video, and it's the one that contains audio. It's some of you might already have seen it, but it gives a pretty good overview zooming into the environment of the Port of Antwerp. So this is a movie where each of the operators will appear briefly on their activities of the Port of Antwerp. So let's have a look and let's have a listen. For those that were having their little nap, please wake up. This is the video.
The new Port of Antwerp Bruges BV-LOS ecosystem offered the ideal environment for the BURDI project, a project co-funded by the EU to implement U-space airspace with all BV-LOS operations mapped to the obligatory U-space services. Let's give an overview of the operational use cases in the Port of Antwerp Bruges ecosystem. With the D-Hive network, the Port of Antwerp Bruges is pioneering with BV-LOS drone operations. D-Hive is a network of automated drones managed from one command and control center. The drones take off from one of 6 docking stations at different locations in the port area. Port planners coordinate the drone flights remotely together with the drone operator. Via the camera inside the drone, they can zoom in on ships, docks, or other port infrastructure. The D-Hive drone network supports Port of Antwerp Bruges in berth management, detection of floating waste and oil spills, inspection of infrastructure such as bridges and locks, and incidents. The automated drones will perform 18 flights per day. Thanks to this network, we have extra eyes in the port area. ADLC is using long-distance BV-LOS flights across the port, transporting petrochemical samples to SGS laboratories, speeding up the analysis of product compliancy and optimizing lead times of ship unloading. Infrabel, the Belgian railroad operator, uses BV-LOS flights to inspect their infrastructure and manage assets in the port area. And Helicus is developing priority BV-LOS transportation of medical samples in the city of Antwerp and its port.
That was the end of the video. It's also the end of me standing in front of you. Feel free to use that QR code that you have seen earlier. Please submit your questions. We'll try all to answer them as much as possible. Be kind to us, I would say. So thank you for your attention. The next session is for Helicus. So please, Mikael, feel free to take the floor and I'll let you speak for yourself. You can explain as nobody else what Helicus does and how you use our platform. So thanks.
Thank you, Jean-Pierre, for keeping us awake. Even though inviting us to sleep, it's difficult when you're talking. Quite interesting, and also congratulations on the BURDI team, but also ÉALÚ-AER, and you're welcome. I mean, we all know that these are not easy tasks that we all undertake, that there's a lot of requirements, a lot of deadlines, a lot of people involved, humans and computers. You never know which is the most challenging of the two. So here we are. Thank you for allowing us also to contribute. Yes, we cannot fly today, but I've heard that also the bridges in the port cannot open, so it's like not only our modality rather, that has natural limits, but it's each of them even like an industry that can be thousands of years old. Huh? So we also have a video. Jean-Pierre also mentioned our team was working throughout the night to actually give you something that I think is pretty unique. So on the one hand, we have put in video reel, let's say all the steps that different speakers and Jean-Pierre just ran through. So, and we have made a video with some steps. We've numbered them just to be easy to follow, as we are the one but last, I think, speaker on a Friday afternoon. So this will avoid you to lose track as it's numbered. And secondly, we have done something special. Well, content-wise, we've activated the B on BURDI. So the B of BURDI does not stand for Belgium, it stands for Benelux. So we've also done, let's say, a cross-border element, let's say using certification at drone operator level, but also at, let's say, a specific application of the Article 13. So I think this is quite exciting, and so I think CINEA will be very happy, and I think Simon as well, that we, let's say, cross-check another one of the list of the long list of, let's say, requirements of the project. So, and also we have tried to follow all the great examples, make it sexy. So we've actually put a very technical process, and you will see the flight path, which is, let's say, going inside and outside the designated U-space airspace, going inside and outside Belgium, into the Netherlands, going back. But we've mixed that with a use case. So you, I think, maybe know Helios as a medical logistics provider, but actually we do general logistics. And so the use case in the Port of Antwerp is we had, let's say, to move. And so we, the other customer group is petrochemical analysis. So we have a few customers in the port. So it's really business use cases. A lot of talks have been going on. How can we move from, let's say, demonstrators into business? So these are flights for customers. And we have mixed the two. So we've put a technical, let's say, step plan, but we've front and backed it with actually use case videos. So it doesn't match. So please find the inconsistencies in the video. I had trouble finding them. I think it's well done, even though it was an overnight thing. It's only, I think, 6 minutes long. So Jean-Pierre said I have a lot of time to speak. So I will not bore you with either a long video or even continue to speak a lot. But I invite you to, let's say, run through. There's no sound, so I can maybe even talk a bit through it. So I don't know if we could launch the video. Oh, sorry, Jean-Pierre, maybe? You wanted to... I could do it myself. Oh. I'll try the green button. I pressed the green button. But I think Christine will help me better. Thank you, Christine. So there we are in the Port of Antwerp, petrochemical installations. You know that surveyors go by bicycle, another modality, to ships, to sample the cargo loads, come back with a few bottles of petrochemical samples. It's, let's say, small volumes, but still touchy, so they're packed in a consistent way to handle them before loading into the drone, according to very specific procedures. Not so easy. And then we go flight. So we create on the C2C side the flight plan based on a integrated risk assessment that we do. Software helps a lot. So just some flashes. So we go through some steps. The flight plans are actually de-risked, mapping with population density, heights, so to provide actually the operator with an efficient, effective planning routine, and to make them also airspace aware. Actually, we're giving a little touch under the hood. This, we're showing a segmented creation, a flight plan in segments. You might know this is not yet fully supported by all the elements in the chain. This is, I think, for the next wave of U-space projects. A key one, so, okay, we are applying it as the base route, and then will this created flight plan will then be injected in the system from the operator. Command and control center will be passing and switching over to the USSP system from Skydrone, our partner here. And we have mixed a bit all the video links to make it, let's say, an integrated example. So you see the different steps. We have there some, let's say, layers that we can click on and off in order to see that according to different risks. So here we have population density popping up, that we actually can minimize the risk. Yeah? So whatever we create, we always submit now to Skydrone, actually to our ESP via the APIs on the selections of date and time, the pre-created, typically flight plan, through an automated process in order to gain speed, of course, and to also ensure full traceability. And speed is of the essence, so all the use cases that we stand for actually make use of the unique selling proposition of a drone, meaning ad hoc, fast solutions. And therefore, we're consistently looking for improving the speed. And then we go to the only single, I think, manual step that we still have in the process, right, Jean-Pierre? So it's a contingency document that we, for safety reasons, need to upload and link to the, let's say, the request. And there we basically refer to the compliances that are being used in order to ensure transparency to authorities. Of course, we should have that already available in the background, and to have this as part of the request process actually maybe something we have to design out. Then the flight approval basically comes. So once the approval by the USSP is provided from Skydrone, we get basically that via digital way. We also do some real-time coordination, by the way, in order to reduce further the operational delay. And so this, you can see, by the way, the frontier between Belgium and the Netherlands running through our flight path. And yeah, it's pretty cool, pretty challenging, and maybe just some flashes. So the surveyor in parallel is actually doing its own pre-flight preparation on the ground, cargo loading, and operations, also following very strict, let's say, steps. And then we move back to the flight plan activation, the LQC2C, and which is synchronized with the Skydrone USSP side, and all via the API-based link. So we basically now received the takeoff confirmation, and there we go. Yeah? So basically we'll set direction towards the border, cross, go back. So we're actually getting out of the designated U-space, airspace, and here we are actually checking the interoperability cross-border element, and continue to have also real live operational validation. So we have strong support during the flight of various parameters. It's a little bit speed up. Anyone an idea what the factor is? Any guesses? 3, 4, 5? It's factor 10. It's quite a long route, actually. It shows to be very small distance, right? But the Port of Antwerp is quite extensive. 120 square kilometers, something like that. So there we are. Miss 10, situation awareness, real-time monitoring is going on. So also live traffic, dynamic airspace is updated. Detailed telemetry, Jean-Pierre mentioned to that, so we're uploading our own telemetry to the USSP and getting an integrated picture via the API back. And then, of course, we need to have a safe landing. Our target of the full flight is actually to land back safe for flight closure. So we ensured full mission traceability, automated data exchange, end-to-end operational closure is now being following. So we're landing here at the lab. We're not making any publicity of any of our petrochemical lab partners at all. So the lab technician is actually now offloading the samples, and then we'll move to the lab for analysis. I can tell you that this trip takes, half an hour to 1 hour easily. When there is the slightest delay, we do it in 8 minutes. And once the quality is actually approved, why is this important, then the ship can actually discharge and be released, can sail away. So every 10, 20, half an hour is a lot of capital assets blocked, right? So voila, I hope this was a good one but last presentation, I guess, or there's more coming, of the afternoon. Yeah. So thanks a lot, and thank you all for all the work you're doing. I mean, I think with nearly all of you, we're continuously having exchanges, so really much appreciated. Thanks.
Good afternoon, everybody. Thank you for having us. I'm Frederik Winters, Head of Business Development for Drone Matrix. We are one of the operating partners in this project indeed, and we are doing this for 2 different use cases. One of them is the Port of Antwerp, as you have seen in the video. The other one is also for Infrabel, as they are also flying with our technology. Because as a matter of fact, Drone Matrix is not only a drone operator, but we are a drone manufacturer. So we built hardware here made in Belgium, autonomous drone solutions, drone in a box solutions, as a matter of fact, that are fully intelligent and automated. So we have the whole value chain of software, hardware, assembly, maintenance and support and operation in own hands, which means that we are flexible with regards to being capable of integrating our technologies into different value chains, operational chains, due to the in-house capabilities that we have. This presentation is going to handle only the Port of Antwerp Bruges component, which was already announced in Jean-Pierre's beautiful video, which is the D-Hive project that we did between 2021 and 2023 and is still operational today, with today already over 10,000 operational flights executed in the port in BVLOS mode. Yeah. And the idea of D-Hive was to offer the port a worry-free drones as a service model. Yeah. We still believe in this model where the infrastructure installation, all operations, maintenance and authorization are carefree for the end customer. Yeah. Meaning that they don't have to invest in knowledge, have to invest in resources, have to invest in everything with regards to obtaining authorizations. And we realized this as a whole in 2023, where we got an authorization for all the installations in the port to operate in BVLOS on demand or based on a planned operation. And the way this works is that we provide, together with our partners in this project, which is Skydrone and Proximus, we provided an end-to-end solution spread over 6 strategically placed installations in the port, yeah, where the port themselves have a few people using the platform to define and plan a flight. They want to do something. They can select which use case, because depending on what they want to look at, the camera combination can be different, or the AI on board can be different, or whatever else is necessary. And they can then define where they want to look. So the flight pattern and the area and so on can be defined by them. And that's where their job ends. They sit back and relax and look at the flight being executed. Because we make sure the flight is authorized, we will execute the flight, and based on the use case detected or selected by the client, the data will be processed and collected after collection and will be handed over on a silver platter to the customer. So the idea is make it worry-free. And I believe that BURDI is a key component in this story, because if drone operations become worry-free, they will start happening. Yeah? As soon as hurdles are there for the end customer, the step to integrate drones in their business is hard and maybe sometimes too hard. Yeah? So that is why we partner also in BURDI, because we want to truly automate this end-to-end process. You need to know that up to 2023, we were busy getting an authorization. And from 2023 until a few months ago, we were busy manually making sure that all flights were truly automated in the sense of getting approval and everything around this. So automatic approval is for us as an operator very important, which means that we need to integrate with the USSP, which means that we integrate with the UTM. And this should also be worry-free. So we should just simply get real-time feedback and confirmation, making sure that we do what we can do and that we can do what we want to do. And the background of Drone Matrix is, like I said, we build everything ourselves, which also meant that we built a whole operating platform for our drone fleet, which is what we call the ARWS, or Aerial Robotics, which are our drones, the work system, which is a fleet and a flight management platform that we use from a Drone Matrix end, which is a data storage environment where customers can consult their video footage and so on. But it is also the platform our clients use. They can request their flights. They can start with plannings and booking in a calendar system, and they can follow up and monitor a flight being executed. And the reason why this works is that we work on a drone as a service model, pay per use. The ideal way would be that you just have a PayPal at the end of your order, you put your credit card in, and you paid for a flight, and we're doing the flight once the payment is complete. That's the worry-free approach we want to achieve. So we integrated the USSP platform with ARWS, which means that the client requests a flight. It is verified by our pilots as, okay, this is a legal flight, because there are still different geo zones, still different areas where we may not be able to fly, and approves this. And once this approval is done, our flight is automatically transferred to the USSP via the aforementioned API. We can monitor then the status on that, and hopefully very soon the confirmation arrives and we can start activating the flight plan. So how does this workflow go? I will show a bit a similar story than the one that Mikael showed you. The client, which is our port planner, for example. Port people are unfortunately no longer here, but they also did this in the past. The pilot from our end receives this request, verifies it, and when reaching a planned time slot, the pilot will then perform the flight. Yeah. I thought there were videos in between. The next one, okay. So I will show you the first one, which is the client request now. So you select an area, a flight plan. Typically, clients, after a while, start creating a lot of flight plans, and they then have a bucket where they can select from and say, I want to do that one again, that one again. Or they can start going to the drawing board and design it themselves. They can indicate a time window and maybe submit some extra information relevant for the pilot, and they can then store this. Yeah. I'm not sure how I can start the video, if it just works on a click. No, it doesn't. I don't have a mouse. Yeah, there it is. Yeah, you can click. Yeah, good. So here you can see an overview. Yeah, you have to look to your screens because it's high res, where clients have a lot of submissions of flight requests that they can do. And when you want to create one, you navigate visually to the area of interest, which is in this case over the Schelde in the port of Antwerp-Bruges, where in this area, this perimeter, a few test flights or a few demo flights or operational flights have been pre-created, which can then be selected or created, or you can change them on the fly. You see a height map, a height profile, you see where the drone will be looking at which point in time when flying after approval. And then you can start planning this. I say, okay, I select this flight plan and I want this to be executed between 12 and 2 p.m. on this dedicated day. So the calendar pre-validates this. Is this still possible with a nearby installation? We still have limited capacity, of course. And then this can be submitted, and it needs then what we call approval in the second phase. Yeah? This approval happens by the pilot. He will edit or validate the request. He will verify stuff, and then finally select a real execution time in the time window defined by the client, and yes or no, approve this. That's the second video to maybe start with the mouse. Yeah. So here we have a similar view, which is for the pilot. He can then open up this request, which is awaiting formal approval internally by the operations. They can take a look at what is happening here. They can go to the details. They see the flight path. They validate this. They say, okay, this is fine. They can comment. They can change, alter, communicate with the client back and forth. And once this approval is given, automatically this is going to be pushed towards the UTM platform, as we will see. Yeah? So here he will strictly define when the flight will actually be exactly executed. Yeah? So maybe this is not at 12, but at 12:30. He will then give maybe a specific name to this identity, which is a unique name per flight that we appoint, so that all the data behind, footage and everything is linked to this. and he will then approve this flight once the information is described. Voilà, this is a demo for BURDI. He will approve it, and this means that also at that point in time, the processing is initiated to the UTM platform or the USSP platform, and we can actually then even take a look at everything from a integration level, how this is working. This information is sent to the UTM platform. Then there's another video. Yep. Voila. So once this information is submitted, at a certain point in time, hopefully almost immediately, the approval arrives back into our system via this bilateral integration of the API, which then allows the pilot to start the operation. Yeah? I will go next. Voilà, and here we can then take a look at the flight execution, which now happens in the cockpit of the pilot. You can see in this cockpit a lot of situational awareness information. You can see in this cockpit this crosshair. It's like a video game, but it's actually a head-up display, as we call this. Every plane and so on in the vicinity of an operating drone will be marked there. So there is a real-time view, a strategic, a tactical view for the pilot. And next to that, you will see all the operational parameters of the drone, like flight time, but also the battery level. You can see a percentage meter, red, yellow, green. You can see a message board, and there's a lot of functionalities that the pilot has to steer and intervene on ongoing operations in case of necessity, of course. Yeah? So to make sure a safe flight happens, the whole operation is monitored by a pilot in BVLOS mode remotely. Yeah? He will then be able to trigger a takeoff. This is happening from Norway. Our operators are physically located in Norway, but they are operating the port of Antwerp. The drone takes off, starts executing a flight path. I will maybe scroll a bit in time, and then you can see here, voila, that the drone has taken off. This is the white arrow, and the ball with the orange center is actually the point of interest where the drone is looking at. And now you can see the drone flying. This is not sped up 10 times like Mikael has done, but it's a one-on-one. So I will speed forward a bit over time. Here you can now see that he's in another area, multiple different zones of interest where the drone is actually executing its flight. Typically, this drone is now gathering video footage, albeit from RGB cameras, traditional day vision cameras, but also night vision cameras we have, infrared cameras, multispectral cameras, different combinations based on the use cases for the client. So this is the operation happening, and the interesting thing is that we can see the similar situation in the USSP platform. Because of course because of the fact that during the flight we are synchronizing in pseudo real time the telemetry to the USSP platform, you can see our UAVs operating similarly here in this environment, which is not the UI or the HMI that we use from the operator perspective, but just to mention this in the context of BURDI, that this integration is end-to-end, not only the approval, but also the real-time telemetry and the deconfliction is fully integrated for this project, and is already in use since a few months, and is the de facto standard now that we apply for all our operations. Well, here you can see the same flight path being flown by the drone in real time. Okay. So that's a bit about it, to be honest. We are an operator, we are a drone manufacturer. We implemented BURDI into our day-to-day operations. So if you have any technical or operational questions, feel free. Otherwise, I thank you and I wish you all a great weekend, because I believe I'm the last speaker. So, thank you.
Thank you very much. Is there any question from the floor? No. So we have a few, I saw a few on sliders, but I also saw that they were responded to in writing, some of them, but let's try and give the opportunity, you know, for people to ask questions here. Otherwise, I think everybody wants to get 30 minutes of their weekend back. So I should say this is my favorite moment, usually during an event, not because it's the end, but because it's the thank you time. So we already heard Kahal extending thanks to a few people in the room, including my own SESAR GU colleagues. I would like to thank as well the technical team. They've been quite on the ball over the course of the past 2 days. And I truly believe that we should also warmly thank all of the speakers and all the teams that have been working behind the projects for several years. And we've seen the results today, so please, they deserve a round of applause as well. So what we've seen is truly collaboration in action, and we know that the best results come from diversity. So European Union, it's about geographical diversity, and maybe you know where I want to get, but there is also the gender diversity. We've had a few female speakers over the past 2 days, so few that I can actually name them, and I will, so they feel supported and welcome whenever they come to us and make their presentation. So thank you to the keynote speakers, Tania, Lucie, and Christine, as well as Patricia, Marie, Marina, and Cecilia, who was sitting here yesterday. So please, they need the support as well. So now I wish to invite Mr. Andreas Boschen, the SESAR GU Executive Director, to deliver his closing remarks. Thank you.
Right, I was there at 9 o'clock, I'm back at 3, and I was in the room. Good, we come to close this DSD event. Like Christelle was saying, thank you very much for your energy, for your openness, and for the commitment. I think we really had useful exchanges here in the room, outside in the exhibition area, and I think this shows how far we have come about integrating drones into European airspace, but also, and this was also very clear, how much work is still ahead of us. We are not lucky today with the weather, you said it, but we were lucky, I think, with getting the hands-on experience. I mean, these videos were really hands-on, and you showed us what you are doing in the project. So what has been clear throughout the 2 days here is the value of dialogue. I mean, we need to talk directly, projects, industry, regulators, service providers, researchers. I would add the political level. We had a member of European Parliament and a member of the European Commission services with us. And all of you bring a unique perspective to it, and together these perspectives are shaping the common vision for U-space in Europe. And it's also clear there's a European dimension. And it will not work only in Belgium, in Flanders, in Occitanie, in Calabria, whatever it is. It is, of course, there is a local dimension, but we are also looking at the European dimension for you as operators. Thanks again to CINEA and the European Commission. Bertrand, you were with us the whole day. You are managing the funding, and we are managing the technical oversight, and together we are really a super team, and this brings, turns these concepts into reality, and we are translating research into operational implementation. So we heard the 3 projects. I will not name them again, but really we could also feel some years ago these were ideas. Maybe, maybe not. And today we see it's not any longer ideas. It is now concrete applications. Yes, we have to scale up. Yes, we have to make the business case, but we have a SESAR innovation pipeline which is not just theory. It is producing and it is delivering. And we have seen the challenges: interoperability across borders, scaling up, integrating drones even more with ADM environment, and building public trust. People should think about drones as something beneficial for them. It's not only the war in Ukraine. We have much better stories to tell than this. are not small tasks, not easy, but together I think we can overcome. And we have shown evidence here during these events that we can do this. Looking at the bigger picture, European Air Traffic Management Master Plan 2025, in this document we recognize the growing role of drones and U-space in Europe's aviation, and we have a course for further investment and deployment. And let's use the results of today to feed into this strategic framework that our achievements on drones are fully aligned with our vision of a digital European sky. Maybe drones can make ATM a bit more digital and a bit more quicker. Would not be bad. Looking ahead, we are preparing now for new research proposals, the next wave of projects. Thank you very much for the many good proposals we got. We are right now evaluating them, and we are soon back to you with the results. So let me finish by saying the digital European sky is not a distant vision. It is something on which we are working, and every project which is delivering, every idea which is validated, every solution which is demonstrated, every partnership which we have built up are step by steps into this reality. So let us take a bit of pride. Let's for once be proud of where we are, what we have achieved, and let's also carry forward the momentum. There was a momentum today from what we have seen, so let us use this momentum for the next step. Continued collaboration across regulators, industry, service providers, innovators, institutions. I'm confident with this we can succeed in making U-space a cornerstone of the digital European sky. And I love to say it always, the world's most efficient and environmentally friendly sky to fly in. So thanks again for your active participation and contribution. We look forward to supporting new ideas and new proposals that will drive the next stage of this journey, and enjoy the weekend. Thank you very much.
And also thank you to Christelle for the presentation. Thank you, Christelle.